Good day, everyone. For lecture 6.2, we're going to talk about the rotational dynamics. So let's get into it. We will first talk about the moment of inertia. When inertia is the resistance of an object to the rotational acceleration. So the resistance. This also describes how a particle mass is distributed relative to its axis of rotation. So in order to solve for the moment of inertia, we have that formula where m is equal to mass, which has a unit of kilogram, r is for displacement, which has a unit of m, I is equal to the moment of inertia, which has a unit of kilogram meter per second. Then, the formula on the past slide is only applicable for cylindrical shell or hoop. But if we have solid cylinder or disc, we will use another formula, which is 1/2 mr squared. But if we have rectangular plate, we will have a formula I is equal to 1/2 m multiplied by a squared plus b squared, where a and b are the sides of the rectangular plate. So for thin rod, about center of the axis of the thin rod is on the center, we will use the formula 1/12 ml squared, where L is the length of the figure. Next, if it is on the other end, the formula will be 1/3 ml squared. Next, for solid sphere, the formula is I is equal to 2/5 mr squared, while thin spherical shell has a formula of I is equal to 2/3 mr squared. Next, let's move on to the rotational kinetic energy. And kinetic energy is the energy in a motion. So it is defined the moment of inertia around the axis of rotation. So it is the moment of inertia on the direction of the rotation. So we have there our formula. K is equal to 1/2 I omega squared, where K is, of course, the kinetic energy, or sometimes on other books they use KE, for kinetic energy. The omega is the angular velocity, which has a unit of rad per second. I will be the moment of inertia, which has a unit of kilogram meter squared. Let's now proceed on the rotational torque, work, and power. So for those three, we have also three corresponding formulas, as you can see on your screen, where T is torque, P is power, W is work, I is moment of inertia, omega is angular velocity, A is angular acceleration, and last, the change in angular displacement, which is a unit of rad. So next, angular momentum. Let's talk about the angular momentum. Angular momentum is the product of the linear momentum and the perpendicular distance from the axis to the revolving particle. So, angular momentum can be expressed as the cross product of particles' positions vector and its momentum. So, for better understanding, we have that formula. Angular momentum is equal to moment of inertia multiplied by angular velocity, or displacement multiplied by the momentum. So, L has a unit of kilogram meter per second squared, kilogram multiplied by meter squared per second. Next. Now, let's move on to the conservation of angular momentum. It is defined that if the sum of the external torques acting on a body or system of bodies is zero, the angular momentum remains unchanged. So below we have the formula I multiplied by omega is equal to I, multiplied by omega sub 0, meaning the final and the initial angular momentum should be equal.
For identical particles of mass 0.50 kilogram each are placed at the vertices of a 2 by 2 square. So, meron daw square na 2 by 2. So, meron daw sa vertices niya, meron daw 4 na particles with mass 0.5 kilograms. So, it is held there by 4 massless rods which forms the sides of the square. So, ito yung mga rods. What is the rotational of the rigid body of about the axis that passes through the midpoints opposites to the sides? So, for example, dito daw meron daw, dito daw yung opposite side, sabi niya. Passes through the midpoints. And we know that the midpoints of a square is here. So, ito yung sa letter A. For letter B naman, with the same drawing, mag-iiba lang dyan yung axis of rotation. For letter B, passes through the midpoint of one of the sides and is perpendicular to the plane. So, kapag perpendicular to the plane, gagamit tayo ng 3D dito. Kasi sabi niya, perpendicular vertical. I mean, passes to the midpoint of one, it is perpendicular. So, for example, gaganito yan. Diba pag sinabi na perpendicular to the plane is ganito. So, mag-iba tayo ng kulay para ma-distinguish niya. So, let's say blue. So, ito yung axis of rotation. So, ang ikot niyan is ganito. Example, dito sabi niya, one side. So, kahit saang side dyan, pwede. So, dito na lang. Ito yung axis of rotation. So, for letter C, so, ito yung mga yon. So kapag titira mo to sa top view, ang itsura niyan is andito yung axis of rotation, andito. So ito yung axis of rotation. So gagawin ko na ring blue ito. Dito banda yung axis of rotation. Kunwari nakatayo yan na. Then for letter C, sabi niya, lies in the plane of the square and passes through diagonal opposite particles. So, ang itsura naman niyan ay ganito. Diagonal, sabi niya. Of two opposites, so bali ganito. Ang ikot niya is ganito. So, nilipat-lipat lang natin yung position ng axis of rotation. So, ang hahanapin ay yung moment of inertia or the rotational inertia. Siya rin yan. So, for letter A, recall that the formula for moment of inertia is summation of mr squared. Because this is just particles. So, ang gagawin doon ay for letter A, we find first the distance from the axis of rotation. So, since itong square ay 2 meters, ang kalahati niyan is 1 meter. So, we have another 1 meter here, 1 meter here. Tapos, another 1 meter here, 1 meter here. So, pare-pares lang naman sila. So, that is equal to the I equals 0.5 kilograms mass. Distance is 1 meter squared. So, apat yan na ganyan. So, we can simplify that as 4 times 0.5 kilograms times 1 meter squared. So 4 times 1 half times 1 squared is just 2 kilogram meter squared. For letter B, again, I is the summation of mr squared. For letter B, ito ang distance nila ay 1 meter ulit. Ito rin 1 meter. So bali dalawa. Ito naman ang distance ito is the shortest distance. So for the shortest distance is this. So you will use Pythagorean theorem here. This is 2 meters. This is 1 meter. So 2 squared plus 1 squared is square root of 5. Square root mo rin yan. So this is also square root of 5 meters. Itong diagonal na to. So magiging I equals 2 times 0.5 kilogram times 1 meter squared kasi dalawa sila na 1 meter. Plus square root of 5 is square root of 5 square is 5. So 5 meters times 0.5 kilogram multiplied by 2. Kasi dalawa din naman sila. So that is 1 half times 2 is 1. 1 plus 5. So the moment of inertia is 6 kilogram meter squared. For letter C, diagonal. So since andun na sa axis of rotation yung particle, the distance is 0. Pero may dalawa pa na particle, so ang distance nila ay ito, saka ito. So this is 1 meter, 1 meter, so square root of 2. This is also 1 meter, 1 meter, so square root of 2. So the distance is square root of 2. That is equal to I equals summation of mr squared. So I is 2 times 0.5 kilograms times 0 plus 2 times 0.5 kilogram times square root of 2 square is just 2. So this is 0 plus 2 times 1 half is 1. 2 times 1 half is 1. 1 times 2 is the answer is 2 kilogram. And the answer is 2 kilogram meter squared. Nagets niya. So you have 3 answers here. That is equal to 2 kilogram meter squared, 6 kilogram meter squared, and 2 kilogram meter squared. That is for A, B, C respectively. A uniform cylinder of radius 10 centimeters and mass 20 kilogram is mounted so as to rotate freely about a horizontal axis that is parallel 2 and 5 centimeters from the central longitudinal axis of the cylinder. So sabi daw we have a uniform cylinder. O diba ganito yung cylinder? Diba? So you have a radius of 10 centimeters. So this is 0.1 meters. And the mass is 20 kilogram. And it will rotate to a horizontal axis. So magdodrawing ulit tayo ng horizontal axis. Hindi siya sa gitna. But that is 5 centimeters. So this is the horizontal axis. So dito daw siya iikot. And that is equal to 0.05. I mean here. So this is 0.05 meters. So for letter A, what is the moment of inertia or rotational inertia of the cylinder about the axis of rotation? So sa axis of rotation. So we will use the parallel axis theorem. So the parallel axis theorem states that I is equal to the moment of inertia of the center of mass plus the mass times the height squared, or the distance from the moment from the center of mass. And the moment of inertia at the center of mass is just 1/2 mr squared, since ito ay cylinder, or you call this as a solid disk or uniform cylinder. It is also referred to as solid disk. Kapag titignan nyo doon yung relationship of various moment of inertia of various solids, or di ba meron yung shell, solids, sphere, ganon. So, the uniform cylinder falls with a formula of 1/2 mr squared plus mh squared. So, we compute 1/2 times 20 kilogram times 0.1 meters squared plus 20 kilogram and height of 0.05 squared. And if we solve, I equals 20 mr squared plus, that is equal to 0.15 kilogram meter squared. This is the moment of inertia about the Z axis, yung pag-ikot ng cylinder. And for letter B, what is, if the cylinder is released from rest with its central longitudinal axis at the same height as the axis about which the cylinder rotates, what is the angular speed of the cylinder as it passes through its lowest position? What will you do here is this. Recall that the rotational kinetic energy is equal to K equals 1/2 moment of inertia times angular velocity squared. And recall also that it has a height. So you will use gravitational potential energy, that is mgh. So by conservation of energy, that is 1/2 IW squared, this is initial, plus mgh initial, 1/2 IWF squared final, plus mghf final. We are looking for the angular speed for the lowest position. And we also know that we don't have any height for the initial case. So this cancels out. And I mean in the final case. So, magka-cancel din ito since at rest siya. So, we are left with the initial gravitational potential energy and the final rotational kinetic energy. Since sabi niya lowest position, so the lowest position it can attain is 0. So that the gravitational potential energy is cancelled. We solve for the WF or the omega F, that is the angular velocity, that is equal to the square root. So WF is square root of 2 times mgh. So that is 2 times mgh over the moment of inertia. Since magta-times 2 sa 2, tapos i-divide mo tong I. Tapos square root yan. So substitute everything is square root of 2 times 20 kilogram times 9.8 times 0.0 ano na yan? 0.05 over the moment of inertia 0.15 kilogram meter square. And the answer is equal to 2 times 20 times 9.8 times 0.05, 0.15. The answer is 11.4 radians per second. Since angular radians. May tanong. So that is the answer, 11.4. For letter A, 0.15 kilogram meter squared. For letter B, 11.4 radians per second. A 0.4 kilogram ball is shot directly upward at initial speed 40 meters per second. What is the angular momentum about P? So this is P. 2 meters horizontally from the launch point here when the ball is at the maximum height and halfway back to the ground. For the maximum height, so the angular momentum is the cross product of R and the momentum of the linear momentum. So that is RP sine theta. So your R is radius, that is 2 meters. Your momentum is mv, so that is 0.4 kilogram times velocity 40 times sine of 0. Since 0 lang siya, kasi ito yung axis mo, your angle is 0. So since 0 yan, 0 na rin to lahat. Therefore, the answer is 0 kilogram meter squared per second. This is angular momentum, so the unit is kilogram meter squared per second. That is for letter A. For letter B, what is the... For letter B, halfway back to the ground. So pag halfway. So that is equal to... We first find the height. So for the height, so kasi sasabi halfway. So we need to find first the height. In order to find the height, we will use kinematic equation. So that is b squared minus bo squared equals negative 2gh. And that is equal to b squared. Your at maximum height, your b squared is 0. Your initial velocity is 40. I mean yung kaninang 0, that is the final velocity, not final height. That is negative 2 times 9.8 meters per second squared, and we are looking for the height. So height is negative 40 meters per second squared over negative 2 times 9.8 meters per second squared. So the answer here is 81.36 meters. Yeah, I mean 63. Sabi niya halfway, so kalahati nito. So we find the velocity. So we set up another kinematic equation that is equal to b squared minus bo squared equals the halfway. So that is negative 2 times 9.8 times 81.63 meters over 2. As you can see, it will cancel. We are looking for V is V. So V is square root. So square root ng, and we know that the initial is also 0. So negative will cancel out. So that is square root of 9.8 times 81.36. And if you calculate that, the square root of 9.8 times 81.36 is equal to 28.24. I mean 63. This is 63. 81.63. And the answer is 28.28 meters per second. So we already have the height. We already have the velocity. So we can now solve for the angular momentum. So the angular momentum is the cross product of R and P. So that is RP sine theta. And your R is equal to, what's your R? R is the radius, I mean the distance. So your radius is 2 meters. Your momentum is mass 0.4 kilogram multiplied by 28.28 meters per second sine of 90. Kasi halfway. So dito, so this is 90. Kapag ganito, this is 90. So since 90 siya, this is equal to 1. So the answer is 2 times 0.4 times 28.28. The answer is 22.6 kilogram meter squared per second. So the answer for letter A is 0, for letter B is 22.6 kilogram meter squared per second. A horizontal vinyl record of mass 0.10 kilograms and radius of 0.10 meters rotates freely about the vertical axis through its center with an angular speed of 4.7 radians per second and a rotational inertia of 5 times 10 raised to negative 4 kilogram meters squared. So you put a mass of 0.020 kilogram, drops vertically onto the record from above and sticks on the edge of the record. So what is the angular speed of the record immediately afterward? So immediately, pagkabagsak pa lang, ano ang sagot? So immediately kasi kapag hinulog mo yan, meron siyang chance na pupunta sa ibang lugar. So set up before we have a horizontal vinyl record. So, meron siyang radius na 0.10. Tapos meron na may radius yan, radius. Then meron siyang mass na 0.10 kilogram. After, meron kang vinyl dyan. Tapos meron daw mass na napunta sa edge. So yung mass na punta sa edge, may mass na 0.020 kilogram. Itong vinyl may mass na 0.10 kilogram. May radius siya na 0.1 meters. So we are looking for the angular speed. So you will use your conservation of angular momentum. That is equal to IOWO equals IFWF or omega. But I used to call this W. So we are looking for the WF. So your WF is IOWO over IF. So that is equal to IO, that is 5 times 10 raised to negative 4 kilogram meter squared. Your initial velocity, initial speed is 4.7 radians per second. And for the final, that is equal to 5 times 10 negative 4 kilogram meter squared plus yung moment of inertia ng particle na dumagdag. That is mr squared since siya ay particle. So that is the mass of the particle multiplied by the radius squared. And if you calculate that, it will have an answer of 3.36 radians per second. So that will be the final answer.
Thank you for listening. I hope you learned something today and see you on the next discussion video.